All right, so I'm going to talk about precipitation, reactions, and writing net ionic equations. So a precipitation reaction is going to be a reaction between two aqueous compounds. They're going to be ionic compounds, and you're going to form a precipitate, which means you will form a solid. It's important to know your solubility rules. There are 4 of them that I gave you. Nitrates are always soluble. Alkali metal compounds are always soluble. Chloride compounds are generally soluble except for with silver, lead, and mercury. Ammonium compounds are always soluble, and I believe that's all of them. So if you are not in that category of things, we're going to assume that you're going to be a solid. So know those 4 solubility rules, and you assume everything else would be a precipitate, solid. And we want to write out these reactions as net ionic equations. So our goal is to eliminate the spectators. We call those spectators, those are the ions that remain unchanged before and after the reaction. They're just kind of hanging out, not really doing anything. We only want to show the species that are actually involved in either making or breaking bonds, because those are the ones that are truly involved in a reaction. And we're trying to figure out what reaction occurs. So we're going to go through a couple of examples. First example here, aqueous sodium bromide. So that is NaBr, aqueous, combines with aqueous silver nitrate. So silver nitrate is AgNO3. So you can see where our nomenclature is important here when we're doing these reactions. So sodium bromide, silver nitrate, they're ionic compounds, and when they're aqueous, when they're dissolved in water, they're going to split apart into ions. So really, sodium bromide, when it's in water, is just sodium ions and bromine ions. They're both aqueous. And silver nitrate is made of silver ions and nitrate ions. And what I know is that 2 of these things can come together to form a solid, because I know that it's a precipitation reaction. So you want to think about your solubility rules and kind of go through your possibilities. What could my solid be? So it's got to be a cation and an anion together. So could sodium bromide be my solid that I form? Well, sodium compounds are always soluble, so it's not going to be that. How about silver nitrate? Nitrates are always soluble, so it can't be that. Could my sodium and nitrate come together? Well, nitrate compounds are always soluble, so sodium nitrate must not be my solid. So what I'm left with is silver and bromide. Okay, so silver and bromide must come together to form my solid. That means that my sodium and my nitrate are actually spectator ions. So what happens in this reaction is that silver ions that are aqueous and bromide ions that are aqueous will come together to form silver bromide, which is a solid. So that's what my reaction would look like. If I wanted to show everything, so this would be my final answer. If I wanted to show the complete equation, just so you can get a sense of what I mean by spectator ions, what we have is, this is what we initially have in the reaction. And afterwards, we have a silver bromide. They're now stuck together, and the sodium ions and the nitrate ions are still hanging out because they're still aqueous. So now you can see what I mean by spectators. So sodium ions aqueous over here, it's aqueous over here. Nothing has changed, so it's just a spectator. Nothing, it's not actually involved in the reaction in any way. It's just hanging out in the solution, kind of watching, right? Nitrate was there before, it's there afterwards, totally unchanged, so it's a spectator. So you can see where my net ionic equation is coming from. The only ones that actually are involved in the reaction are these 2 things, which combine to form this thing right here. So let's try another one with lithium hydroxide. So lithium hydroxide looks like this. In reality, when it's dissolved in water, it's going to be split apart into the lithium and hydroxide ions. Magnesium chloride is MgCl2. It is going to be split apart into magnesium and chloride ions. Okay? And again, I'm looking for who will combine to give me a solid. So it's not these guys. It's not these guys. How about if I put lithium with chlorine? Well, all alkali metal compounds are soluble, so that's not my solid. So that leaves behind magnesium hydroxide. So the way to use your solubility rules is whatever's on your list is soluble. If it's not on the list, then assume it's insoluble. So magnesium hydroxide are not on my list of things that are soluble, so I'm going to assume that means they come together to form a solid. So what happens is the magnesium and the hydroxide, they are going to stick together. When they stick together, keep in mind this is an ionic compound, so you have to consider charges. So magnesium has a +2 charge, hydroxide has a -1 charge. So if you do a little crisscross, you'll find that when they form a compound, they'll make MgOH2. That is the solid that I formed, otherwise known as my precipitate. Still hanging out in solution are some lithium ions and some chloride ions, and they are just spectators. Notice how they look exactly the same before and after. So I want to eliminate those spectator ions. Okay, so my final reaction is going to look like this. It's magnesium, aqueous magnesium ions coming together with hydroxide ions to form this magnesium hydroxide solid. And I should say at this point, I should stop and say, hey, wait a minute, this is not balanced. I have 2 hydroxides over here on the right, I only have 1 over here on the left. So now I'm going to stop and I'm going to balance it. I'm going to put a 2 right here in front of the hydroxide. So balancing means you need to have the same number of each type of atom on the left as on the right, because atoms cannot be created or destroyed. They cannot appear from nowhere. So whatever's here at the end must have been there at the beginning. So this is my net ionic equation. I'll do one more example here that's possibly a trickier one with these charges. So let's do this one. If we have nickel 3 chloride, which looks like this, combining with, let's do potassium carbonate, which looks like this. So, and they're going to come together and form a precipitate. So we want to write the net ionic equation here. So these are going to break apart into ions. So we have a nickel ion. How do I know the charge of nickel? Well, I know that there are 3 chlorines for every 1 nickel, so my nickel must have a charge of +3. Okay, and these are both aqueous. I've got 2 potassium ions, and I've got a carbonate ion. So this is what I have over there in my reactants. In my products, I formed a solid, so 2 of these things must have come together and stuck together in solid form. So what are your options? Well, could it be potassium and chlorine? Well, all potassium compounds are soluble because it's one of my alkali metals. So it must not be these guys. What else could it be? Well, I've got a nickel and I've got a carbonate. And those aren't on my list as being soluble, so that means I'm going to assume it's insoluble. So nickel carbonate, I'm going to put it together. Nickel's got a +3 charge, carbonate has a -2 charge. Don't forget to consider charge. Use my crisscross method. I need 2 nickels for every 3 carbonates. Once I do that, I'm going to erase the charges because now this compound is neutral, and this is the solid that I formed. I still have these chlorines and potassiums hanging out. They were there before, they're there after. They're not doing anything. Okay, so those guys right there are my spectators. So I'm going to rewrite this in net ionic form. And I'm going to say I've got some nickel ions that are aqueous, and I'm going to combine them with some carbonate ions that are aqueous, and I'm going to end up with this nickel carbonate, which is a solid. And I should stop and say, wait, I have 2 nickels over here, but only 1 nickel over here. Nickels can't just appear out of thin air. If I have 2 on this side, I must have had 2 over here to begin with. So I'm going to stop and balance it. Okay. Same thing with my carbonate. I have 3 carbonates on the right. That means I must have had 3 carbonates over here on the left. So with your net ionic equations with precipitation reactions, they also look very similar. So cation plus anion gives you solid. Make sure you're writing the charges of your ions. Make sure you're stopping and balancing to make sure you have the same number of each atom on each side of the equation. Label your states of matter. And check the formula over here. So ask yourself, do I need subscripts? What should my subscripts be? Consider charge. You're always going to be making ionic compounds in this type of reaction. So in an ionic compound, your total charges must add up to 0. So there are some examples of how you write a net ionic equation.